So imagine yourself in this scenario. You are in a room with perfectly reflective walls, and the room is in the shape of a perfect ellipse. You are in this room, and you have a gun, and you're standing on one of the focus points of the ellipse, and your enemy is standing on the other focus point of the ellipse. The question is, in how many ways can you fire your gun and kill your enemy? And the answer is infinite. What I love about ellipses so much is this really fascinating characteristic that they have that has to do with what are called angles of incidence in physics. Basically, this is what it means. If you are in a perfectly elliptical room and you're standing on one focus point and you fire your gun in any direction whatever, the path of that bullet, it's going to go in any direction, bounce off the wall, and go through the other focus point. So, if you shot it, say, in this direction, the angle of reflection is going to be such that the bullet is deflected and will go through the other focus point. And this is true in any direction. You can shoot it, in this direction, whatever. No matter what, it is going to bounce off the wall and go through that other focus point. So, if your enemy is standing over here, it doesn't matter where you fire a gun. You will always be able to kill your enemy just by shooting it. Of course, the trivial case is if you shoot it in this direction, then it's going to bounce back and kill you before it gets to your enemy. All right, but that's the only way I guess you can't kill your enemy. But if we think of, I started off with a rather violent example, but we don't have to be so violent. There are places in the world that are called whisper rooms, and they do exist out there, where the room is essentially in the shape of an ellipse. And if you stand on one focus point and your friend stands on the other, you can speak at a whisper in any direction, and they will hear you perfectly over here. So if you're standing at this focus point, and let's say you whisper in this direction, the sound waves that you are speaking are going to radiate out of your mouth, right? But every sound wave, when it hits the wall, it's going to reflect, and all of these sound waves are going to converge on this point, right? So think of all these different lines as being like a bit of sound. So the bit of sound that kind of trails off this way, well, that's going to converge over there. And the bit of sound that goes here, it's going to go over here. The bit of sound here, it's going to go over here, etc., etc. And because the sum of all these distances are equal and the speed of sound is constant, that means all of the whisper that you say in this direction are all going to, all of those sound pieces are going to arrive back here at the same time. So if you're standing over here and your friend whispers over here, it's going to sound like they're standing right next to you because all of the sound waves are going to hit you at the same time. It's brilliant. There's something else I want to point out about this. You can also do this with what do they call ripples in water. If you have so I would encourage you to look in your kitchen. If you happen to have a bowl that looks like it might be an ellipse, see if you can calculate where the focus points are. If you have a bowl of water, a vessel of water that is perfectly elliptical, well, it doesn't have to be perfect, it can be pretty close, and you drop a rock on one of the focus points, that's going to generate, ripples of water, right? Like throwing a stone in a pond. But all of those ripples are going to radiate out from the focus point, bounce off of the edge of the dish, and converge back on this other focus point. But if you have two, ripples that are coming head on, and they're in the same frequency, they're going to cancel each other out. So if you can find a bowl that is perfectly elliptical and you can drop something at one focus point, it's really cool to watch because you have still water, you drop the stone, ripples all over the surface of the water, but then a second later, the water's completely still again because all of those ripples of water converge back on this other focus point and cancel each other out. And it's remarkable to see. So there are a lot of really cool things about the ellipse. This is just kind of a few of them. That these angles of incidence are such that they always reflect back to the other focus point. I love that. It's a really lovely characteristic. I'm going to post a few other videos from YouTube that kind of demonstrate something like this. But I would encourage you to look around your house, see if you can find something that is close to an ellipse, and see if you can do something to play with this. You can do it with sound, you can do it with water, pretty much any kind of fluid, air is a fluid, and kind of test out this property. This is unique to the ellipse. We're going to see it's going to carry over in a way with our next conic section, that of the parabola, but it's going to be a little bit different. Anyways, so I just wanted to share that with you, and keep an eye out for a couple of videos that kind of demonstrate this really fascinating, really beautiful property of the ellipse.